And what's going on, everybody? Let's go ahead and get into today's lesson. We are going to be having a nice discussion, hopefully not a confusing one, about circle word problems. So if you're sitting here thinking that geometry specific word problems, like circles, like dealing with circumference and diameter and radius and all those things, if you feel like that's a lot to handle and it's confusing, I can empathize with you. I can absolutely empathize with you because it is a lot of terminology. But the one thing that we have to understand is when it comes to geometry word problems, specifically like circle word problems, you have a huge advantage because there are specific keywords and terminologies that have to be used. So we're going to be understanding how this really comes together when it comes to understanding radius, diameter, circumference, and the areas of circles. Now, once we get through that, once we actually get through the formula part and understanding these things, then we're going to understand those keywords and where to look in the right places in terms of turning the English into math. So, with that, let's go ahead, my party people, and get started right away here so that way we have a lot of time for the word problem practice today. So, first things first, let's understand the difference between the terms radius and diameter. Let me go ahead and highlight these two terms here in different colors. And let's go ahead and draw ourselves a circle right here. I can draw a perfect circle, no help from technology needed. There we go. As always, perfect. Now, everybody, when it comes to the radius of a circle, the radius is pretty much from the center to the edge. That's it. From the center to the edge. When it comes to the diameter, it is the distance all the way across the circle, through the middle. So let's go ahead and say we have the middle of the circle being right here. So if we try to write the distance from the middle to any edge, any part of the edge, that is the radius, my party people. That is the radius. The diameter, if we want to do a little bit of word knowledge here, diameter, the prefix di means 2. So diameter would mean 2 of those radiuses or radii. But long story short, radius is just from the center to the edge, and the diameter is going to count from edge to edge. You still have to go through the center. So my party people, before I give you a second to write this down, I'll give you plenty of time to write this down before we move forward. Do we have that in our heads? The radius is halfway. The diameter is all the way through. Right on. This is one of the most important things to learn from the get-go. So I know this might seem like a refresher or something that's just a simple fact that we just have to know, but it's more than that because it's going to come down to the word problems and understanding whether or not you're given the radius or given the diameter to start. Because some problems, and we'll get to them, some problems are not going to say that the radius is 5 or the diameter is 10. No. Not at all. They're going to say something like, hey, there's a statue in the middle of this circular pond, and the distance from the statue to the walking path is 25 meters. They're going to do it like that. And I know that's going to drive a little bit of anxiety with my crowd right now, but these are the things we have to prepare for. How to turn the English into math. So with that said, let's take a moment here and write down the notes that we have on the screen, including trying to draw a perfect circle on your paper right there. And then we will move forward once we're good. All right, let's take it forward here to the next round of notes. So this is where we're going to be talking about the circumference of a circle. So first of all, quick question, what the heck is the circumference? So the circumference is essentially going to be very similar to the word perimeter. My party people, what word do you associate with the word perimeter of a shape? What do you typically associate with perimeter? And let me go and copy this real quick for a moment. Yeah, and paste it right there. There we go. Yeah, so when we think about perimeter, we think about the word outside. And that's exactly what circumference is. Circumference is the distance on the outside of a circle. The only reason, my party people, the only reason that we are using a different term, circumference, instead of perimeter, The only difference is that shapes, traditional shapes like triangles, squares, rectangles, pentagons, yada, 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 those have flat sides. A circle doesn't really have sides. It's just one large curvature all the way through. So, long story short, not trying to bore you, circumference and perimeter are the same exact idea, where we are basically talking about the distance around the shape. Circumference is specific for circles, perimeter specific for other shapes. My party people, are we good on that before I continue explaining? Just making sure that that's, again, one of those facts that we just have to know, that it's going to be very important to understand because it helps us out in the future. Right on. So again, circumference is the same as the perimeter. I'm going to write this down for us, no problem at all. I gotcha. So circumference is the same as perimeter. So if I go ahead and draw a path going around this circle, that's what the circumference would be. That's what it would be, the distance around the circle. Now, there are a couple of ways to calculate the circumference, two different ways that we're going to talk about today. Number one is if you're using the radius, and number two is if you're using the diameter. So take a look right over here. Like we said again, the radius is from the center of the circle to the edge, any place along the edge, and then diameter is going all the way through. Now, let me go ahead and highlight the one that uses the radius right over here, and the one that uses diameter right over here. So here's the difference between these two formulas. There is none. They are the exact same formula. They give you the exact same number, the exact same circumference. I just want to point out, everybody, that remember, the diameter, everybody, can you give me a yes or a no in the chat box? Is it true that I said that the diameter is double the radius? Is that true? Right, absolutely. I just wrote it down 40 seconds ago. The diameter is indeed double the radius. So yeah. So what would happen if I tried to replace the diameter with the radius? Well, I would replace it with double the radius. And that's why when you look at these two formulas, look, if you take away that pi symbol, the only difference is this one says d, this one says 2r, or double the radius. So these are the exact same formulas. One is just, hey, if you have the radius, you can use this one. Or if you have the diameter, use this one. But they're interchangeable. They are interchangeable because the diameter here is double the radius, 2r. 2r and the d are the same exact thing. Now, I'm not asking you if this makes 1000%, hey, I'm ready to get a master's degree in mathematics sense, but does the basic idea that the diameter is double the radius, so we can write the formula two different ways, does that part make any sense? Good, cool. Because I'm not trying to over or under explain. I want to give you just enough to be able to succeed, given that we're just trying to pass this standardized test. So again, my party people, before I give you the timer here to take your notes, the circumference is the distance around the circle. And it's, again, the same as perimeter, but because a circle doesn't have sides, we can't call it perimeter. We just have to use a different term. Either formula works. You can use the radius for one, the diameter for the other, and that's it. The last thing I'll say is that there are problems that will prefer that you keep the pi symbol right there, that you keep this pi symbol as pi, and there are other problems where they'll prefer that you approximate or estimate pi as 3.14. They will let you know which one to use. Pi is, again, approximately 3.14. It's an infinite irrational number that you cannot really ever try to write. So you use the symbol pi whenever you want to use exact values. But if the problem says, hey, use 3.14, that's basically telling you to just replace pi with 3.14. And that's it. Now, if you're asking me what pi means, pi is essentially the ratio between the diameter and the circumference, as you can see right there. So the circumference is always pi times the diameter. That's the ratio that's given. Again, I'm not going to try to over or under explain things, so I will leave it right there. That's correct. Pi is the ratio. So with that, let's go ahead and take a moment here to write these notes down. Hopefully you weren't trying to write as fast as I was talking, because I really do want you to just put your pencils down when I'm talking, understand what I'm saying, and of course I will give you that time to write things down. I got your back. And let's move it forward here to the area. So the area formula, my party people, let me go ahead and just paste the same image again. Remember that there is a big difference between area and circumference. Remember that the circumference is going to be the distance around the circle. The area, it's going to be the space inside of the circle. Let me go ahead and highlight this here in green. So again, the area is going to be the amount of space that the circle takes up. So all of this, and actually I believe I can go ahead and just do something quick here and fill this in with green. Perfect. Even though that's a horrible green, I think that's better there. There we go. The area of a circle, again, is going to be the amount of space inside of the circle. And the formula, there's only one that we use for it. It's going to be A equals pi r squared. My party people, quick question, pop quiz question. Which is the only one that can be used in the area formula? The radius or the diameter? Which one is the only one that can be used in the area formula? Yes, that's correct. It's the radius. We see it right there. That says r. That is r. Pi r squared. So in terms of the order of operations, what this tells us to do is take that radius and square it and then multiply it by pi. So don't worry, we'll go ahead and go through those exercises and examples. And again, for the benefit of making sure that we are not trying to over-explain too much and go down the rabbit hole of where the area formula came to be, because it just has to do with angles going around 360 degrees. And if you're into calculus, it has to do with integrals and integration by parts. But again, we'll leave that for another day. The formula that we'll be using is area equals pi r squared. Right now, you are better off, again, memorizing these formulas and then getting ready to be able to use them as we translate English into math. But again, R here, it stands for radius right there. So one more time, my party people, let's go ahead and take a second, write these final notes down, and we're gonna get straight into today's practice and examples. Let's move it forward here to the first of 4 examples. So my party people, let's go ahead and talk about this. Let's say we have some problem where we're given a radius of a circle and it's 8. My party people, if we were asked to find the diameter, what would the diameter be? If they tell us that the radius is 8, what is the diameter? Interesting. What's that gonna be? Now, I love these 2 responses that I'm getting. First response is 16, and the other response I'm getting is 2r. And those are both going to be valid explanations or valid answers. That is gonna lead you to 16. Everybody remember, the diameter is double the radius. Remember that. Again, let me bring this back from a couple of slides ago for our notes. But again, the diameter is double the radius. Let me put that right there. Let's draw the circle out. Just as a reminder, everybody, just as a reminder. And let me get that green out of here. Give me one moment. Okay, so remember, my party people, the radius goes from the center to any part of the edge. Again, the radius is the halfway, not the full distance. If we're going from edge all the way to the other side, that's the diameter. That is double the radius because, everybody, because if we were to go ahead and go from the center to the edge over here, guess what? That's another radius. That's another radius. So if you go from the edge to the halfway point, that's 1 radius. From the halfway point to the edge, that's another radius. Double the radius is the same as the diameter. That's what I'm talking about there, my party people. So again, if we have the radius being 8, the diameter is 2 of those together, and that'll be 16. My party people, yes or no? Does that make sense? Is that something that we feel like we can remember even during those high pressure situations, like being timed for a practice problem? Right on. And yeah, that's right. All I did was 8 plus 8 because, again, the diameter is 2 of those radius together. It's called radii, but whatever. Hey, right on. There we go. So with that said, let's go ahead and take it to the next question where, like I said, I'm going to put you under a timer and I'm going to give you 5 seconds. Here we go. 5, 4, 3, 2, I'm kidding. What is the radius here? I am giving you a diameter of 12. What is the radius? All right, so it looks like the majority of us are saying 12, or excuse me, 6, are saying 6, and that would be correct. Now, really quick, who here felt that anxiety build up? Who felt that heart rate elevate when I said, you only have 5 seconds? Yeah, and that's gonna be pretty common, right? That's gonna be pretty common, especially as you are performing or practicing something that isn't quite committed into memory like that, right? It's not really second nature yet, so obviously you're not gonna feel 1,000% confident. And that's what that anxiety kind of feels like. So with that, yeah, I wasn't gonna give you a full stakes word problem in 5 seconds. I'm here to be realistic. So let's go ahead and understand this one. So given the diameter of the circle is 12. Okay, let's draw the circle. There we go. And let's draw the diameter here from edge to edge, because that's what the diameter is. From one edge all the way to the other, just like that. And they said the diameter is 12. Remember, everybody, the radius is the halfway. The radius is half of the diameter. So let's check this out here. Again, the radius would be from the center to the edge, not all the way through. No. Just about halfway. And so with that, that would make it half of the diameter. The radius would be 6. Because again, if we have 2 of those radiuses or radii, what we would have here, put this over here, that's what would make the entire 12. 6 here, 6 there, and that's what makes a total diameter of 12. So long story short, to go from diameter down to radius, cut it in half. To go from radius up to the diameter, double it. Again, that's the relationship that they have. The radius is half the diameter. Diameter is double the radius. My party people, with that said, are you understanding that relationship in that sense? Yeah, we're not really adding or subtracting technically. It's more so multiplication and division by 2. All right, perfect. All right, so let's go ahead and do another one here. Just off the cuff, let's go ahead and try another one out. So I'm either going to give you the radius or the diameter. I want you to give me the other. All right, my party people? So if I were to give you, radius is 4, I want you to give me the diameter as, well, it should be 8 in that case. So let's go ahead and try this out for a couple here. Number 1, let's go ahead and say the radius is 3. What is my diameter? Go. 3, 2, 1, and that is correct. It's going to be 6. All right, up next, number 2. Let's say we have a diameter of 3. What is that radius going to be? Oh, y'all are good. Yes, that is going to be 1.5. Because remember, the diameter is the bigger one. The radius is half of it. So if the diameter is 3, we cut that in half and we get 1.5. If you're not so used to working with decimals, it is something that I would highly recommend you sharpen your skills on, because it's something that just takes time to work on, and it's not anything that is, ridiculous, just as long as you put in that consistent effort. I got you guys, no worries at all. So when you want to think about how to cut 3 in half, you can think about 30. 30 cut in half is 15, but since it's 3, not 30, it's just going to be 1.5. Now let's try another one here. Number 3. So let's say we have a diameter of 10. What is my radius going to be? That's correct. My radius is going to be 5. Because again, diameter is the bigger one. Cut it in half to get the radius. And that's how we get 5. Let's go ahead and keep it up here. Let's do a couple more before we move on. Number 4, let's say we have our radius is 12. What is that diameter going to be? Yeah, diameter is not going to be 6. It's going to be 24. Because remember, The radius is the smaller one. Diameter, di meaning 2. The diameter is double the radius. So we have 12 for that radius, double it to get 24. So even if we just made a mistake there and we said 6, are we starting to appreciate the understanding here between the radius and diameter, even if we made a mistake? Cool, sounds good. I don't want this to feel like torture for anybody or a heart attack there that I saw in the chat box. Make sure to stay hydrated and inform your nearest medical professional if you are experiencing any math PTSD. So number 5 here, next one, we have the diameter is 16. What is that radius? Right on, and that is going to be 8. Correct. Again, diameter is the bigger one. So if we're trying to go down to the radius, we cut it in half. That is right. And we're all good there. So with that said, my party people, do we feel like that was enough of a warm up so we can move on to trying out circumference and area? Right on, right on. Math PTSD is crazy. No, welcome to my classes. So with that said, let's go ahead here before we move forward to our next one. Before we move forward to practicing with circumference, I want to ask y'all, pop quiz, which one is the formula for circumference that uses the radius? Write that down for me. So there are 2 circumference formulas. I'm going to ask you first, again, for the one that uses the radius. What is that one going to be? Just write it out, type it out in the chat box. You should have it written down on your notes. Rely on those notes. Perfect. Yep, the one that uses radius is going to be 2 pi r. That is correct. Now, if we wanted to write down the one that uses the diameter, pop quiz, what is that one going to be? Correct. That is going to be pi times the diameter. That's right. That is correct. And just one more time, for anybody who was trying to understand the relationship earlier but didn't quite, remember that the diameter is the same as double the radius. Remember, these 2 formulas, they are the exact same. Whether you use the radius for this one or the diameter here, you will get the same circumference, the same exact one. So with that, let's go ahead and try this out. When I show you this example problem that's coming up next, I don't want you to give me the answer. I want you to immediately write down the formula that we should use. Immediately write down the correct formula. And make sure you use C equals. I don't want that lazy 2 pi r or pi d. I want you to write C equals 2 pi r or C equals pi times d. Either one's fine. Just make sure to include that C in the beginning. Here we go. Which formula are we using? I'll give you 12 seconds. 10 and 5, 4, 3, 2, and 1. Which formula should we be using for this one here? Right on. So again, I promise you my goal is not to freak anybody out. It's only to get you ready and equipped to recall information as needed as quickly as possible. That's all we're practicing here. No pressure. Notice that if we get it wrong, not the end of the world. I really just want you to get acclimated to the kind of environment you want to prepare for. So the correct answer that I'm looking for the formula here will be circumference equals 2 pi r. Why this one? Well, it's because we are asked to find the circumference, so we know we're using circumference formula. Yeah, I prepared you for that. But right over here, notice that it says we are given the radius of the circle as 4. So, my party people, just as a reminder, if we're trying to find the circumference and we're given the radius, use the formula that uses the radius. If they gave you the diameter, hey, then you can use the formula that uses the diameter. I'm not trying to make it crazy or complicated. That's as simple as it gets. If you're looking for circumference, you have 2 formulas that achieve the same goal, depending on which you have the radius or diameter. My party people, how much sense does that make on a scale of 1 to 10? Again, you have 2 formulas for circumference. They give you the same thing. They give you the same exact value at the end, but you just got to make sure you plug the right numbers into the right one. Right on. So with that said, let's now go ahead and plug in the number that we have here and try things out. So everybody, here we are going to keep pi as pi. So everybody, does that mean we replace pi with 3.14? Is that what that means? Correct. That is a no. You keep the pi as pi. Remember, they'll let you know. And if they don't say it in the question prompt, they will say it in the answer choices, given if there is a pi or not. So you're good there. So with that, again, we are just going to plug in that radius being 4 right there. That's all we're going to do. And then we have c equals 2 pi times 4. Now, this is where we're just going to go ahead and clean things up, combine like terms. Really, if we're getting super technical, we're using the commutative property of multiplication. I know it's fancy. I know it sounds fancy. But all that means is the 2 and the 4 can be multiplied together because we can just rearrange the multiplication. So the answer that we get at the end of the day is 2 times 4 pi, which is 8 pi. And that's our circumference in this problem. And there we are. And there we are. So with that said, my party people, again, radius and diameter, they are related to each other. The radius is half of the diameter. Diameter is double the radius. So with that, are we ready for the last example before we move into the word problems? Right on. Let's go ahead and slide on over here. All right, my party people. When I show you this problem, I am going to give you, again, I'm going to give you 15 seconds this time. And I want you to write down the formula that we should be using. Again, I'm not asking you to do any math. I'm not asking you to do jumping jacks or anything of the sort. I just want you to use your notes depending on what the problem says. Given the diameter of a circle is 14, find its circumference. And 7, 6, 2, 1, and time. What is our answer? That's correct. The circumference is what we're looking for. And just like I said, if we are looking for the circumference, we have two options for that formula. It just depends on what we're given. And it says here, the diameter of a circle is 14. So I know that I can use the pi times diameter formula because I'm given the diameter. So circumference equals pi times diameter. There we are. We're all good. And we're done. We plug in the 14 for the diameter and we get c equals pi times 14, which is also going to be written as 14 pi. And there we are. And there we are. My party people, who here feels like, hey, if you just magically memorize the formulas, including the one for radius and diameter for circumference, that your life would actually be pretty easy because now you understand radius and diameter a little more. There you go. Remember, everybody, I know I say this in every single class. It is not about memorizing the formulas. It's about understanding the components therein. Again, one more time, it's not about memorizing the formulas. It's about understanding the components therein. So that's why I take so much time to really go through these pieces, because once we get into those word problems, we'll be much more able and equipped to interpret what's going on. So let's go ahead and give the next one a go. And just to answer your question, Louis, the reason that we're not multiplying by pi is because the problem here directs us to just leave the pi as pi. That's why. And again, we get the 14 because the diameter is 14. And the formula says, hey, multiply pi times the diameter. Since the diameter is 14, there we are right there. And since we're just going to leave pi as pi, pi times 14 just comes out as 14 pi. No more work can be done, so we'll leave it as that. Yeah, no problem. I got your back. So with that, I want to go ahead and introduce us to our first word problem of the day. Now, here's how I want us to do this. I don't want you to give me an answer first and foremost. I want to play it just like we did right now. The first thing I want you to do is tell me what formula we should be using. But for this first one, I'm going to make it even easier than that. For this first one, the first thing I want you to do is I want you to tell me what the goal of the question is. And for those of you who are here for the first time, the first thing we do, everybody, the first thing we do is we read the question sentence. We don't read the whole problem start to finish. No, we go straight to that question sentence right there. And we understand what's going on. Like, what do we want to do with this problem? What's the end goal? So with that, here is the first question. I want you to read the question here, right there, and I want you to tell me in the chat box, what is it that we are trying to solve for? In a few more moments here, really give it some good thought. So to complete a full lap along the edge, what is the total distance he covers? So everybody, think about it. Think about it. If we're trying to do a full lap along the edge or around the border, what are we trying to calculate here, especially if we're talking about a circular track? So we can draw that here. I got you. So if we have, let's say, a circular track and we're trying to jog one lap around this circular track, does that sound like we're trying to find the radius, diameter, circumference, or area? Which of those four does it sound like we're trying to solve for? Yeah, and the correct answer here is going to be circumference. The correct answer is circumference. The reason, again, my party people, is that if you're thinking perimeter and you're wondering, why didn't coach say perimeter? Remember that perimeter and circumference are the same thing. Circumference is just specific to circles, but it's the same premise. We're just trying to find the distance around the shape, around the circle in this case. So my party people, even if we made a little mistake, it's all good. Remember that mistakes are going to happen. How we respond to those mistakes and how we really recover and asking why we got it wrong and what we were supposed to do, that's really all we need to do. We need to do there, and we can move forward. So with that, now that we can interpret that we are trying to find the circumference, everybody, how many formulas are there for circumference again? How many formulas? 1, 2, 9, 12, how many? Yeah, there are two. Now, follow up, which one of them should we use here? The one that uses radius or the one that uses diameter? Which one should we use? Yeah, correct. The one that uses the diameter. Right here, check it out. It says the track has a diameter of 50 meters. So right there, the diameter is 50 meters. So now that we know that we are looking for the circumference and we know that we are given the diameter, everybody, does that make it a lot easier to point out which formula we're supposed to be using? Oh yeah, right? And that's the difference between starting from the very beginning up here and then letting that anxiety and that lack of confidence lead you to assume certain things. That's the difference between that and having a calm, cool, and collected presence here saying, okay, one full lap, so we're going around along the edge. Okay, that's circumference. Total distance, that's circumference. Now I got two formulas. I see diameter right there. Perfect. So I know that I'm using this formula. And all I have to do now is replace the diameter with the 50 that I have right there. And boom. And that's the difference. That's where that confidence can come in, everybody. But there's one thing that we're forgetting. What is the one thing that we're forgetting here, my party people? What's the one thing we have to do that we haven't quite done yet? Yeah, notice. My party people, did they say leave pi as pi? Did they say that here? No, they didn't say leave pi as pi. Not at all. Also, do you see pi in the answer choices? No, we don't see pi in the answer choices either. So that should be your clue, right? Even though we don't see them say, hey, use 3.14 as pi. Even though they don't say that, we can interpret that because we see that our answers don't include pi. So that should be your giveaway that, yeah, I'm going to have to go ahead and approximate pi as 3.14, and I'll multiply the 50 by it. With that said, are we ready to have me calculate with the 3.14 and move on to the next one? Sweet. Let's give it a shot here. So this is going to be a nice little refresher on dealing with decimals and multiplication. So we are going to do 3.14, and we're going to be multiplying that by 50. So here's a quick refresher on multiplying by decimals, everybody. Number one, when we multiply, we're just going to ignore the decimal. Just multiply like normal. Ignore the decimal. Just multiply like normal. And then number two, once you're all done, at the end, we'll bring the decimals back. We will bring the decimals back. So let's go ahead and tackle this step by step. And I got you. So step one, let's multiply. First thing I'll do is I'm going to highlight this in blue because I'm going to take care of the 0 first. So 4 times 0, that's going to be 0. 1 times 0, that's going to be 0. 3 times 0, that's going to be 0. Look at that. Look at that. That was the hardest multiplication I've done probably all day long. So with that, here we go to the next. We are going to now move over to the 5. And so that means we need to start on the second place value right here. So with that, here we go. We are going to have 5 times 4, and that's going to be 20. And I'll carry that 2. Next, we're going to have 1 times 5, which is 5, carrying the 2, and that's going to give us 7. Next up, my party people, we now have 3 times 5, and that's going to be 15. And there we are. Now, we'll just add those 2 rows together, and we're good to go. So 0 plus 0, 0 plus 0 again, 0 plus 7, then the 5, and the 1. So that was step 1. Again, just multiply like normal. We did that. Step 2, we're going to bring the decimals back. Everybody, how many total decimal places are we bringing back? If you said 2, that is correct because we have a total of 2 decimal places. Up here on the first number, we have 1, 2. On the bottom number over here, we only have, well, nothing. With the decimals right there, there's no movement. So again, it's going to be a total of 2. 1, 2, giving us a total distance around that lap, that circular track as 157 meters. And that's what makes the correct answer here, A, approximately 157 meters. And there we are, my party people. There we are. Notice how once we know what we need to calculate and the numbers we need to use with it, that's it. It's just a matter of plugging and chugging from that point moving forward. So I'm going to just remind you and just help you really get into this again by saying that the most important part of any word problem is understanding the goal of the problem first, and then number 2, the information you have. What do we want? What do we have? And that's how we'll build that connection in terms of the formula we need to use and then the calculation after the fact. So with that, my party people, if you're asking, hey, 3.14, is that what we always use for pi? Correct. If they tell us, hey, we are going to approximate pi, they'll typically give you 3.14. But if they don't give you anything at all and they just say, hey, just approximate the circumference, still 3.14 is the safest bet. Anything other than 3.14, they will let you know. But 3.14 is the standard approximation for pi across most standardized tests. So with that said, my party people, how are we feeling about this first one? More, particularly speaking, how are we feeling about understanding that, hey, talking about a circle, going along the edge, hey, that's circumference. How comfortable were you with recognizing the words and turning that into the math idea? Not very good, feeling so-so about it? No worries, I got you. Let's go ahead and kick it forward here. Let's try another practice problem out because we all know that we're just here to get one problem better, one problem at a time. So with that here, let's go. We see here that it says, what is the distance around the edge of the fountain? My party people, what are we trying to calculate here? What are we trying to calculate with this problem here? What is the distance around the edge? What is our end goal? Yeah, so if you said circumference, you are correct. That is absolutely correct. If you're trying to find the distance around the edge of the fountain, so let's just go ahead and say that this is our fountain here, and we have water on the edges, filling in. Well, guess what? If we're trying to find the distance around the edge of the fountain, let me use a different color. That is the circumference. That is the circumference. Distance around the circle. That is correct, Ariane, because of the word around. So with that, now we want to ask, well, which formula are we going to be using? Do we use the 2 pi r or do we use the pi times d? Which one of these formulas is the right one to use? And tell me why, actually, because I see a lot of us using the correct answer. That's correct, 2 pi r. But can you give me the reason why? Can you give me the reason why? Why are we going to be preferring to use 2 pi r versus pi times d? There, yep, it's as simple as that. It is as simple as saying, hey, they gave us the radius. I'm going to use the formula with the radius simply because we are given the radius. It doesn't have to be any more complicated than that. And that's the great thing about geometry. If you have what you need, you have what you need, and you can keep going. So with that, booyah. And once I plug everything in, everybody, c equals 2 pi, and the radius was 10, right there, that's what they say for the radius. Do we have to replace pi with 3.14 in this problem, everybody? Another correct answer. That is a no. We do not have to because the answer choices already include pi. So we are going to leave pi as is. And this is a great time to tell you that the symbol pi is the same thing as the word pi or pi. They are the same thing, and problems can feel free to use them interchangeably. Some standardized tests will prefer the symbol, while others might prefer to use the word. So I'm going to use both in this study session to make sure that you know which is which, because they're really the same. And again, you will know to use 3.14 if they explicitly say, hey, use 3.14 for pi, or if you know that the answer is supposed to have pi, but it's just numbers, then you know that you should be approximating pi as 3.14 and calculating with that. And no worries, that's a great question, Louis. Great question. Again, how do we know? And you want that confidence. So that's just a question rooted in wanting that confidence. I respect it. You're good. So with that in this problem, to finish things up, 2 pi times 10. All we need to do here is take the 2 and the 10, multiply those together. 2 times 10 is going to give us 20. So the answer is 20 pi. So our correct answer here is B. And there we are, my party people. Boom, that's number 2 knocked down. How do we feel about this one, everybody? Are we feeling more confident as the practice continues? Right on, let's go. So with that, I want to go ahead and give you a shot at this next one. So here we go. Let's give this one a shot. Boom. So a circular flower bed has a radius of 8 meters. What is its area? My party people, what are we looking for in this problem? What are we looking for here in this problem? Again, what's the goal? What do we want out of this question? Not what do we have? What do we want? There we go. Yeah, we want the area. Read the question sentence. If I start here, I'm reading the problem. The problem is that we have a circular flower bed and it has a radius of 8 meters. The question, the goal is here. Who, what, when, where, how many, which of the following? What is its area? Right there. So in this problem, what we want here is the area of a circle. And everybody, how many formulas are there for the area of the circle? Yeah, there's only one formula. And what is that formula going to be? The area is going to be equal to pi r squared. That's correct. Pi r squared. And so with that said, my party people, do we have everything we need in this problem to plug in? Do we have everything we need to get the answer? Yeah, I'll agree with you. That's correct. We do. We absolutely do. Tell me in the chat box, everybody, this R stands for what? The R stands for the radius. Correct. R stands for the radius. And so let me actually, whoever's watching the recording, I want to make sure you can see that clearly. My pen just slipped. There we go. So we plug the radius into here. So with that said, my party people, we have the radius. Radius of 8 meters. So let's go ahead and highlight that. Everybody, we are replacing the R with what again? Just want to hear you say it. Yeah, it's going to be 8. So we have pi times 8 squared. Question, are we replacing pi with 3.14? No, I don't, at least not yet. Yeah, sure, B and, just B doesn't have pi in it, but A, C, and D have pi. So I'm going to leave pi as pi. I'm going to leave it as pi. And if whatever this turns into is one of these, then hey, we're good. We are good. So everybody, help me out here. Calculate with me because I'm going to be super confident. I am super confident right now that when we do pi times 8 squared, we're going to end up getting 16 pi, right? Right? This is me as your coach. I'm forcing you to agree with me. I'm kidding. No, that's going to be incorrect. And so for anybody here who is adamantly believing that, yeah, we should be getting 16 pi, let me actually help you understand why that's not the case. It's actually a very common mistake. So let me not make you feel bad. It's a very common mistake for people to interpret squaring something as doubling it, but it's not the same. I got you. So let me just take a red highlighter and just do that to make sure you clearly see that it's wrong. And over here, let me just remind you that if we have 8 squared, my party people, remember that squared, or any exponent really, that tells you how many times you're multiplying this number by itself. So 8 squared means you're going to have 2 8s multiplied together. 8 times 8 twice. Again, 8 times itself, like that. My party people, what is 8 times 8? 64. That's correct. And that's why pi times 8 squared is going to turn into 64 pi. Because 8 times 8 is 64. So that makes pi r squared 64 pi, making C the correct answer. Just like that, my party people. And there we are. So question here. So when do we add and when do we multiply? So I've never, at this point in class, we haven't really added. I think you're wondering, when do we, double or cut in half? And remember, that's going to be the interchanging the relationship between radius and diameter. So from radius to diameter, double it to get the diameter. To get back down to the radius from the diameter, cut it in half. That's that. Yeah, I got you, Lewis. No worries. I knew that's where your mind was. I got you. And then again, for circumference and area, 2 different formulas, and you have to interpret what you got from there. So at this point, I'm going to ask my party people, do we feel like we're ready to try to work under a timer, to try to practice these problems on our own to see if we can interpret what the goal is, what we have, the formula we need to use, and then following through on that math? Hey, I love that response. Who was that? Who said that? Oh, Nikoi. No, but I want to give it a shot. I respect that all the way. So with that, let's go ahead and get it done here, my party people. So let me give you a timer here, and let's try the next one out. All right, let's go ahead and give this next one a shot here. Let's get it going. So if I were to begin the problem by just reading, a circular plaza is designed such that a straight path goes, what would be wrong with that, everybody? Besides the weird accent I'm using? Yeah, I want to read the question first. We want to read the question first, everyone. Regardless of the size of the problem, could be a sentence, could be 10 sentences, doesn't matter. We want to start with the question first. So right here, what is the distance around the edge of the plaza? Everyone, if we are correctly assuming, that we are talking about a circle, my party people, if we are asking for the distance around the edge of that circle, what idea are we talking about? Yeah, we're talking here about the circumference. Again, if we are discussing this circular plaza and we are discussing the distance around the edge of this circular plaza, we are discussing circumference. And I'm going to write that over here. I'm going to write down circumference. Now, there's a little bit of an issue. The issue is that there are 2 formulas for circumference. There's the first one, which is circumference equals 2 pi r. And then the other one, which is circumference equals pi times the diameter. Again, the one on the left here, this one sports the radius, and the one on the right uses the diameter. But remember, they are the same exact formula, giving you the same circumference at the end. It just depends on which property you use. And that's it. So with that said, I don't think that this problem actually explicitly says radius or diameter. Everybody, is that true? The problem doesn't actually explicitly say the word radius or diameter, right? Yeah, and that might be a problem for some people. That might be a problem for some folks. And this is where it's important to understand how to translate the key words that you see in the problem into the math. So no worries, I made this on purpose in this way. I gotcha. So with that said, let's give it a go. It says a circular pizza plaza, or a circular plaza, sorry, I'm hungry. A circular plaza is designed such that a straight path goes directly across its center, measuring 30 meters. Ooh, that's pretty particular there, right? That's pretty particular. It goes directly across its center, a straight path directly across the center. Let me see if I can draw what that might look like. Let me zoom in over here. Let's say this is my center, and I'm going to draw a straight path that goes directly across the center on that plaza. Everybody, what does it sound like I just drew? Yes, correct. This is what I love about these classes, where we can go from that anxiety, that lack of confidence to saying, oh, yeah. By the way that we said it and the way that we drew it, I can be confident that I know what this is. Correct, my party people. That is the diameter. That is what the problem gives us here. And it measures 30 meters. So we can write 30 meters as our diameter. So with that said, everybody, are we using formula number 1 or formula number 2? Which one should we use? That's correct. We're using formula number 2 because this is the diameter. Again, it's as simple as that. Doesn't have to get more complicated. So let's zoom on in here and let's plug in the diameter that we have, which is 30. So we have pi times 30, which, again, if you look at your answer choices, all of the answers contain pi. That tells you, that implies that we don't have to use 3.14. We will leave the pi as is. That right there stays as is. So pi times 30 is the same as 30 pi. And there we go. There's our answer. And my friends, we are done with this specific problem. The answer here is B, 30 pi. So notice how this is less about your ability of calculating, with pi, without pi, all that stuff. It is more about understanding the words that are given to you and translating the English into math. My party people, are we seeing that? Right on. Again, that's really what we're testing you on here in today's class. It's really about, can you translate the English into math? So with that, again, hopefully we are not too angry about getting fooled on some of these questions. Remember, these are just going to be qualified as growing pains. But if you are looking to get your anger out, again, that drywall just down the street at your local Ace Hardware or Lowe's is going to be on a discount. So feel free to get a cardboard cutout and express your anger. So with that, let's go ahead here and try this next one out. I want to give you another chance here. Let's put us under a timer and let's give it a go. So with that, here we are. Let me get the timer and here we are, everybody. Let's give it a shot. So using this measurement, what is the area of the pond? So in this problem here, we're given what we want to know. We want to know the area. And when we're dealing with circles, as we have been in this class, there's only one formula that we're dealing with. Pop quiz, everybody. Go ahead. Give me the formula. Give me the formula that we're going to be using for the area of a circle. That's going to be area equals times the radius squared. Exactly. There we are. Area equals pi times radius squared. So there we are. So what that means is, everyone, to solve this, to do this the right way, we need to have the radius right here. So this is where we, again, have to pay attention to the wording of the problem, and we need to see if we're given the radius or not. And if we're not given the radius, the real question is then, how can we get to the radius from what we have? So let's read it. A circular pond is designed such that the distance from its center to any point along the edge is 6 meters. Everybody, let's interpret that again. So if we're talking about a circle, a circular pond in this case, and we're told that the distance from the center to any point along the edge is 6 meters, what did we just describe? Exactly. We just described that radius. So we know we're good. We know we are definitely good to go. So that means since we have the radius equals 6 meters, boom, plug that in right there. And from there, we're good to go. We just have to make sure we calculate the right way and we're good. So pi times that radius squared. Everybody, what do we do first? 6 times pi, or do we do the 6 squared? Which one comes first? Yep, that's correct. We are going to square it. That's right. We are going to square it. So that is going to be area equals 6 squared, which is 36. Again, 6 squared is the same as multiplying the 6 by itself. So we have 36 pi. And there we go. All good there, giving us an answer D, 36 pi. Are we ready for the next one, my party people? We're doing a good job so far. Let's keep it up. Heck yeah, right on. So let's go ahead and move it forward here to the next one. And let's give this next one a shot as always. So the easy part of the problem is understanding the question here because it says, using this information, what is the area enclosed by the park? Okay, sounds good. What is the area that's being enclosed here? Everybody, there's only one formula for area. So pop quiz again, give it to me in the chat box. What is the area of a circle? Correct. That is going to be area equals pi times that radius squared. So let's be very clear again. Let's be very, very clear. Everybody, we are going to need what about the circle to plug and chug? What do we need before we can plug and chug? Yes, we need the radius. We absolutely need that radius. So with that said, let's see what we're given here. I see a number here, 18 meters, but what does that represent? So a circular park has a straight path stretching directly across its center that measures 18 meters. Okay. Let me go ahead, draw a circle, and let's say that we had, again, the straight path directly across the center from here across all the way, and that is 18 meters. Okay, my party people, are we given what we need? Do we have what we need? Do we just plug in the 18 and say, have a good day? Is that what we're supposed to do here? Is that what we're doing? No, correct. That is not the case. How do we know that that's not the case? Again, it's all about understanding your formula. Your formula here, my party people, says that we require the radius. What we just described going across the circle entirely through the center, that is the diameter. So this is where you just have to take a quick moment, a nice quick moment to remind yourself that if I want to go from the diameter to the radius, which again, the radius is just going to be halfway, then we will cut it in half. And that's it. Remember, the formula requires radius. If you are given the diameter, well, remember that the radius is the same as half of the diameter. So since the diameter is 18, my radius is half of 18, which is going to be 9 meters. Just like that. We just had to take a quick moment to calculate what that radius was. But now that we have it, we're all good. Because now we can plug it in, which we have right over here. Pi times 9 squared. And then we're good to go. Everyone, 9 squared, or 9 times 9, what's that going to be? Correct. That's going to be 81. 9 squared is 81. And so our answer will be 81 pi. Remember, if we wanted, if we were trying to do the 18 times 18 right here immediately, that's simply because we jumped the gun. That's simply because we forgot to ask ourselves, hey, this 18 that we're trying to plug in, is that actually the radius? And that was not the case. So remember, I think we've all been there before. My party people, you tell me in the chat box, have you been there before where you've done a problem that it took you a while to wrap your head around and you still got it wrong, but then once you had it explained to you, you were like, oh, wow, this is actually super easy. I just forgot to pay attention to X, Y, Z. Yeah, and that's what can happen. Remember, math isn't always all about calculating. Math is also about reasoning. And that's where paying attention to the wording and the goals, that's where that really comes into play. So with that, let me go ahead and explain this problem again before we move forward to the next one. I got you, everybody. Remember, it's a patient process. So with that, here we go. So the goal was the area. It was the area. Our formula for the area, there's only one of them. It's pi r squared. So what was required of us here, my party people, was this. If I wanted to use this formula, I need to use the radius. When they described the straight path stretching directly across its center, straight path stretching across the center, not starting at the center, but going across the center. That's how we know that they're describing diameter. That was the big problem. We have diameter, but we needed radius. And that's where we went back to the beginning of class where we took our notes and we said, hey, to go from diameter to radius, cut it in half. Because remember, the diameter is double the radius. So to go back to the radius, you cut it in half. And that's where this here comes into play. And once we had that, everybody, boom, we got that. Half the diameter, half of 18, that's 9. So that's what we're supposed to plug in. That's what we plug in. And once we had that, then we're good. Pi times 9 squared. 9 squared is 81. They didn't say to remove the pi. And so there it is. 81 pi, and we're all good. So with that, are we good to try another one out? Are we good to be tenacious here and keep it going and give it another shot? Let's go. I got y'all. So here we are. Let's go ahead and move it forward. And here we go with the next one. So the question here reads, specifically, to complete one full lap along the edge, what is the total distance he covers? So my party people, just with that context alone, if we're trying to complete one lap along the edge of anything, if we're trying to go around one of anything, typically we would call that what? I know we're trying to use the word circumference, which you are correct. But if we're talking about anything other than a circle, what's the proper term for squares, rectangles, perimeter? That's right. If we're trying to go around a sided shape, yeah, we are going to be talking about perimeter. If we're going around a circular object, that's going to be circumference. So we have two formulas that we can go off of. Number one is going to be the circumference equals 2 pi r. Again, if we have the radius. The other one is going to be pi times the diameter. And that's going to be if we have the diameter. So with that said, everyone, which of the two are we clearly given in the wording of the problem? Yeah, we're clearly given the diameter right here. Right there, it says the track has a diameter of 120 meters. So with that, booyah right there, that's what tells us which of the formulas to use. So my advice for those of us that are refreshing on this and practicing this, it's really going to be this. It's going to be continue using your notes until it's clear that you understand beyond memorization, that you understand these formulas. And so, continue doing that. And then once you don't need your notes anymore, hey, you're good. You're flying on your own. So right here, we're going to be using pi times the diameter. And everybody, are we going to be replacing pi with 3.14 in this problem? Correct. Yes, we are. Yes, we are. The reason is when you take a look at your answer choices, and none of them are using pi. None of them use the symbol for pi. So with that said, we are going to use the approximation, and that's going to be 3.14. Remember, that's the approximation. I'll write it again for us. The approximation for pi is 3.14. Just a fact that we really do need to know. And so we have 3.14 as pi multiplied by the diameter, which is 120. Now, we are going to do this multiplication here, but we don't have to torture ourselves. We don't have to, because one way to write this is going to be 3.14 multiplied by 120. That is one way to write it. My party people, when we take a look at this, who here is excited about doing a 3 by 3 digit multiplication? Who's excited about it? I love the sarcasm. I love the sarcasm. That's how you know you're my student. So with that, we're not going to be doing 3 by 3 digits. We don't need to. Yeah, it's just going to be a 0 there. One thing that you can do is this. You can go ahead and let's go ahead and say, let's pretend here. 3 times 2 is 6. 3 times 20, well, that's 60. All I want you to pay attention to here is that if you have a 0 when you're multiplying, all you do is just really stack it on the end. That's really all you do at the end. So we don't really need to multiply by 120. We can multiply by 12 and then just bring that 0 back at the end. That's really all we got to do. And that can save us a little bit of time. But in case, worst case scenario, you've got to do the 3 by 3, just do the 3 by 3. But in this case, because we have that 0 at the end, we can just put it at the end. We're good. So let's do it that way. 4 times 2, that's going to be 8. 1 times 2, that'll be 2. 3 times 2, that'll be 6. That was row number 1. Row number 2, right over here. We're going to go ahead and put the 0 first. And now we'll go 4 times 1, that'll be 4. 1 times 1, that'll be 1. 3 times 1, that'll be 3. Add it all together, and we're going to have 8. Then 2 plus 4, that's going to end up being 6. 6 plus 1, that'll be 7. And then the 3 will just be there. And now that we're here, my party people, with that said, how many decimal places are we bringing back? Correct, that's going to be 2. We have 1 and 2 right there, 1 and 2 right here. So our final answer here will be 376.8 meters, which when we round this, if we round it to the nearest answer that we have, because again, we see the word approximately being used, what is the closest answer that we have to 376.8? And that's correct, my party people. That's going to be A, 377.0. And there we go. Yep, in this case, very clear here that we want to round up because the 8 at the end is larger or is 5 or bigger. Remember, if that decimal or if that digit is 5 or greater, then yeah, we'll go ahead and round up. And there we go. So with that said, I think we can definitely try to do one more problem before the class ends for sure. But I want us to just reflect on where we are now, because you know how I'm big on this, especially if this is your first class. This is something that you always want to do. So think about where you were from the beginning of class to where we are now. Do we really feel like we've gained some confidence, everybody? Do we feel that way? Let's go. Right on. Also, Charles, right on. I'm going to read that message at the end after I'm done recording this class. But I think I just saw that you passed as well. So congratulations to Charles in the chat box there. I will read that and pull that text that you sent because it got drowned out real quick. But I want to finish up class here. But thanks for sharing that. I really do appreciate that. I'll let Isabella know the kind words that you said. So with that, my party people, let's go ahead and get one more problem in before the end of class. We got this. All right, so straight to the question first. As always, what is the distance around the edge of the fountain? Everybody, hit me. Are we looking for circumference or area? Correct. That is going to be circumference. Distance around. We're going around the circle. We're not looking at the space inside the circle. It'll be around the circle. So that's what we've got. Circumference equals, and we have two formulas. We have 2 pi r, or we can use the circumference equals pi times the diameter. So with that said, everybody, which one of them are we going to be using? The one with radius or the one with diameter? Yeah, the one with radius. We see the radius right here. Radius of 37 meters. So we definitely want to use the first formula. Absolutely. So with that, circumference equals 2 pi r. And with that said, we'll just plug and chug. Notice your answer choices. They all use pi. So because they all use pi, we don't need to replace pi with 3.14. We're good. So we'll just go ahead and write it out. Circumference equals 2 times pi times the radius, which is 37. And then from there, we'll go ahead and rearrange because remember, we can now multiply 2 and 37 together. Nice and neat on the side. 37 times 2. That's going to be 7 times 2. That's 14. Carry the 1. Then 3 times 2, that's going to be 6. Carry the 1 is 7. 74 is what we have. So that will make our final answer 74 pi. And there we go. There's a final answer. Booyah. And that concludes today's class, everybody. Remember, it's always going to come down to 2 things before you leave. It always comes down to 2 things when it comes to word problems. Step 1 is going to be translating the English into math. Step 2, that's where you actually calculate. And I really hope that today was a very good exercise in staying calm, staying cool, staying collected, analyzing the information first before you decide to go gung-ho and calculate. I really, truly hope that this was a good exercise in teaching you patience when it comes to math, especially when the test that we're taking, we're under pressure, we're under a timer, and that's what this is all about, everybody. So I really do enjoy teaching y'all, and it was a pleasure teaching y'all. Hopefully I will see you in the next lesson that we have, my party people. But until then, you know what to do. Continue practicing with the tools that you have under circles and practicing circumference and diameter and radius and area.